In this lesson, we're going to start looking at how different compounds form bonds. The first thing that we need to learn about when we are talking about chemical bonding and representing it on paper is learning about something called Lewis symbols or Lewis dot diagrams. So Lewis symbols are Lewis dot diagrams. They're used to display electrons found in a particular spot in the atom. They're representing the outermost shell, and you might have heard them being called valence electrons before. So they are the ones that are the furthest away from the nucleus, and how we're going to represent them in our diagrams, we're going to draw dots. So similar to the idea of Bohr-Rutherford diagram, where we're just going to do the ones in the very last shell. Just like Bohr-Rutherford diagrams, for most of the shells, the maximum that these diagrams can hold are 8 electrons or 8 dots. How do you figure out how many electrons go in a diagram? Well, this is where your knowledge of the periodic table comes in. You're going to take the numbers of the families, those are the columns, on the periodic table. You're going to look at them and they're going to tell you how many valence electrons an atom has, and then we're going to put them in our diagram. So here I've got a modified version of the periodic table. We're not going to bother with the transition metals or the lanthanides or actinides. We're just looking at the alkali metals, the alkaline earth metals, your metalloids, nonmetals, and a few representative metals over here. To get the group number, we're just going to count across. So group 1 is the alkali metals, group 2 are the alkaline earth metals. Jump over all these ones here and then just keep counting. 3, 4, 5, 6, 7, 8 across. So everything in group 1 has 1 valence electron, or it will show 1 dot. Everything in 2 has 2 dots or 2 valence electrons, and that continues all the way over to the noble gases where there's 8. So how do we draw the dot diagrams? These are very, very easy once you know that trick with the periodic table. So I'll show you one for calcium. So to draw it, you would draw the symbol of the element, which you already have, is calcium, and then you're going to look, where is calcium on the periodic table? Which group is it in? And you should be able to find it in group number 2. So that means it's going to have 2 dots. So in my diagram, I'm going to put 1 dot and then 2 dots. We try and space them out on the top, bottom, left, and right, and pair them up afterwards. So that's what a dot diagram looks like for calcium. Not too bad. What if you have an ion? You can also draw dot diagrams for ions. So I'll show you one down here. When you see a negative charge, it means there are extra electrons. So when I do the sulfur ion, the sulfide ion is what it's called. First, I'm going to do sulfur on its own. So I draw my symbol for sulfur. Then I'm going to go look on my periodic table and have yours handy. What column or what family is sulfur in? And when you look, you should see it's in 6, group 6. So I need to put 6 dots. 1, 2, 3, 4, 5, 6. I put them by themselves and then I pair them up. It doesn't matter which order going around you pair them up in, but you need to put them by themselves first. Do not go 2, 2, 2, 2 all the way around. It won't work for what we're doing next. Okay. Then I have to put in my extra electrons 2 because it's a -2 charge. I can't put more than 2 together, but look at that. Here is one place for that 1 electron, and here is a spot for the other. So those extra 2 electrons go here and here. When I have an ion, I have to do one extra thing. I have to put a bracket around the element, and then I need to write the charge. So the same charge that's up here, I'm going to write up here. So at this point, what I would recommend you doing is pausing the video and see if you can figure out what the dot diagrams are for all of these other elements or ions that are here. So pause the video when you're ready to pick it back up. We'll take them up together. So next one we have germanium. Germanium is in group 4. So GE should have 1, 2, 3, 4. Next, oxygen is in group 6. So it's going to have 6. 1, 2, 3, 4, 5, 6. Bromine is in group 7. 1, 2, 3, 4, 5, 6, 7. Then I look to neon. Neon is in group 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Next, I go to potassium. Potassium is in group 1. So it only needs 1 dot. So those are all of the atoms that are there. Now we'll take up the examples with the ions. Now, I didn't give you one with a positive charge before, but maybe you were able to figure it out. So let's walk through this one. Lithium is in group 1. Normally, it has 1 electron around it like this. But when you have a positive charge, you're going to lose an electron here, or more depending on what the charge is. So positive 1 means it's going to lose 1 electron. So guess what? That 1 electron that we just drew in, we're going to get rid of it. Since it's an ion though, we still follow the same pattern. Put the bracket around and put the charge up top. So it only had 1 valence electron, but as an ion it loses it, so we don't put any electrons around it. It still has other electrons, just that valence shell is now empty. Next, we go to chlorine. Chlorine is in group 7. So I put my 7 dots in. -1 means I have 1 extra electron. There's 1 extra spot for it. So I'm going to pair that guy up, put brackets around it, and then again, I'm going to put my negative charge there. Last one, nitrogen. Nitrogen is in group 5, so 1, 2, 3, 4, 5. -3 means I'm going to add 3 more electrons, and look at that, there are spots for 3 more. 1, 2, 3. And then don't forget that bracket going around there. So that's how you draw Lewis dot diagrams for elements or ions. Next, what we're going to do is talk about ionic compounds, some properties that they have, and then how we can use these dot diagrams to show bonding in ionic compounds. All right. So, ionic compounds. First, let's review what they are. This is something you should have learned in grade 10. So ionic compounds, they form a bond, and it's caused by electrostatic forces. What that means is a positive and negative charge, something that's positive and negative attracting each other. But here, that positive and negative thing is going to be a positive ion and a negative ion. The positive ion is going to be a metal, and the negative ion is going to be your nonmetal. So when you look at the formula for an ionic compound, it's always a metal plus a nonmetal. Compounds that form when a metal and nonmetal join, ionic compounds, have certain properties. So that means characteristics. So what are they? When you look at them, they usually form white solid crystals at room temperature. If you measure their melting and boiling points, they are high. And when we talk about high, we mean super high, like greater than 500 degrees Celsius. You might think 100 degrees Celsius is high, but no, we mean very high. Boiling point would be definitely over 1,000 in most cases. These types of compounds dissolve very easily in water, so they're very water soluble. When you dissolve them in water, they conduct electricity, and that's because there are ions present that float around in the water. If you were to smell ionic compounds, they generally have no odor or it's very weak. And here's an example you might be familiar with: NaCl, or sodium chloride. This is table salt. So if you can think about table salt and see how it might fit into these categories, you'll get an idea of what ionic compounds look like. Table salt is white. Table salt forms solid crystals. If you've ever looked up close at it, it's cubic, looks like a cube. You've probably never tried melting or boiling it because you wouldn't have a use for that. But it dissolves really well in water. You often put that into boiling water when you cook pasta or other things. Then you know it dissolves in water in the ocean, in seawater. So if you're trying to think of a really good example of what an ionic compound is, think table salt. That's the best one that you should be familiar with. Next, what we're going to do is learn how to draw an ionic compound. How does an ionic compound form? And how do we use our dot diagrams to do that? So if you don't have a periodic table out already, you probably did from before, but grab it again and have it handy because this is where you're going to need it. So we're going to walk through the steps, then we'll go through some examples. Step 1, if you're not given a chemical formula for the compound, you need to make sure you figure out how many atoms you have, and we'll go over that first. Next, what you're going to do is draw Lewis symbols for each atom, and then you're going to show how electrons are transferred. Electrons go from the metal, the positive ion, to the nonmetal, which is the negative ion, using arrows. We'll walk through those steps together. Last step, draw the atoms as ions in square brackets, just like we saw before with those dot diagrams. We'll see those brackets again. And we put the charges around them. You'll see electrons are around the nonmetal, and there will be no electrons around the metal. So let's take a look at an example together. So step 1, I need to make sure I have my formula. So you want to draw a Lewis structure showing the formation of a bond between magnesium and chlorine. So if I don't have the formula for when magnesium and chlorine combine, this is what I have to do. I'm going to go to my periodic table and I'm going to write the symbols down. The metal comes first and the nonmetal comes second. So Mg is magnesium and Cl is chlorine. Then I need to look on the periodic table for their charges. It should be in the top right-hand corner of the one that's posted on our website. Charge for magnesium is +2, but really we just need to know that it's 2. When you look at chlorine, the charge on chlorine is -1. Once you write those charges on top, then you're going to do the crisscross. 1 comes down here, and 2 comes down here. Then you get Mg. We don't usually put 1s in formulas, remember, so leave that blank. Cl, and then we put a 2. So this is the formula that I need before I can actually start drawing my diagram. That's step 1. Now step 2, we're going to need to draw dot diagrams and show where the electrons go. So from my formula here, I need 1 magnesium. So I'm going to draw it first. And magnesium is in group 2. So I need 2 dots. Then comes chlorine. There are 2 chlorines in the formula, so I need to draw 2 of them. I'm going to keep my metals on the left side and put my nonmetals on the right side and space them out a little bit so you have some room. Chlorine is in group 7, so I need to draw 7 dots around chlorine. So this part hopefully should look familiar from when we did the dot diagrams, but now I have to show the transfer of electrons. The metal is going to give the electrons to the non-metal. What's going to happen? Take one of the electrons from the metal and find an electron to pair it up with. It's going to go here. I have another electron, but I can't put it around the first chlorine because now all of them would be paired up. So I look to my other chlorine and I can see, yep, there's a spot for it there. You continue doing this until you give away all the electrons from the metal to the non-metal. Then the last step, I have to draw my ions with brackets and charges and put electrons around the non-metal. So first, we're going to put magnesium. Magnesium does not have any more dots around it because we gave both of them away. So right away, I can put my bracket around magnesium and write my +2 charge there. Then I have to write chlorine. So chlorine will have 8 electrons or 8 dots around it. Each of them gained 1. So it's going to be full. I have to put the bracket around it. Each chlorine gained 1 electron, so that means it has a -1 charge. And here's a little shortcut. Since there are 2 chlorines, this happens twice, so the easiest way to do it is put a 2. And if you look at your formula up here, 1 magnesium and 2 chlorines, 1 magnesium and 2 chlorines, it mirrors that pattern there. Your charges, you can also double check on your periodic table in the top right hand corner. So if you're not sure where the numbers come from, go to your periodic table and double check. And that's all there is to it for your diagrams for drawing ionic compounds. So next up, I'm going to give you a few minutes to try drawing 2 Lewis diagrams. So the first one is for lithium and sulfur, and the second one is for calcium and nitrogen. So at this point, I want you to pause your video, see if you can draw these 2, and then we'll walk through the answers together. All right, welcome back. Let's walk through these examples. So lithium and sulfur, lithium has a charge of 1 and sulfur has a charge of 2. So when I do the crisscross, I get Li2S. So in my diagram, I need 2 lithiums and 1 sulfur. I'm going to draw lithiums. They both have 1 dot around them. Sulfur has 6. Then I'm going to show the metals giving away their electrons. So one is going to go pair up with this electron, and one is going to go pair up with that electron. Then I'm going to do the same thing. Lithium is the metal. Put my brackets around it. It has a positive charge, and there are 2 of them. Sulfur comes next. It keeps all of the electrons around it. There's only 1 of them, but it has a -2 charge. So there's your ionic diagram for lithium and sulfur, which makes lithium sulfide. Again, if you haven't tried one of these, please try them out. Pause the video, give yourself a chance and come back. Next up, calcium and nitrogen. Calcium has a charge of 2, nitrogen has a charge of 3. Do your crisscross. So you should get Ca3N2. So that means you've got a few more atoms to deal with here. 3 calciums, which is okay. Calcium is in group 2, so they each need 2 dots. Then I'm going to do my 2 nitrogens over here. Nitrogen's in group 5. So here there's a lot more arrows because there's a lot more electrons to pair up. So I just start pairing. One goes here, here's another one, pair up here. There's still 1 extra nitrogen here, so my next electron I'm going to put there. This calcium still has 1, so I keep pairing up. This has a partner, and this one has a partner. So now all of the electrons from the metal are partnered up with the nonmetal. So the calciums have no electrons around them. They all have lost 2 electrons, so they have a positive 2 charge. 1, 2, 2 here, positive for losing. How many do I have? 1, 2, 3. So I put my 3 there. Then comes the nitrogen. All of them are full. They each accepted 1, 2, 3 electrons. Again is a negative charge. And there are 1, 2 nitrogens. So I put a 2. So the trick with this is just getting some more practice, getting comfortable using your periodic table. It also does a little bit of review with some formulas. So hopefully that helps understand a little bit more about how ionic compounds form.